The next thing we have is, it is a very important theory, and there is a printing mistake also, typing mistake. You have something like, since pressure plus half rho v squared plus rho g h equal k constant. This is the thing typed in the note. This is also correct. This is correct. This is the Bernoulli's equation, the full Bernoulli's equation. But right now we are discussing about horizontal pipes. So there should not be this term here. This should be like this: P plus half rho v squared equal K. So you can just cut that term. If it is already corrected in your tube, that means it is an updated newly printed one, so you don't have to worry about that. From this equation, from this constant equation, we can understand that at places where velocity is high, in order for the sum to be constant, if the velocity is high, rho is always constant, pressure should decrease. If the velocity is high, pressure should be low. So under this line, it is typed as at places where area is small. When area is small, we know using the continuity equation, if area is small, then velocity is high. If area is small, velocity is high. If velocity is high, for this sum to be constant, pressure should be small. Okay, so the other way around is, if area is high, from this equation, if area is high, velocity should be low, velocity should be less, and if velocity is less, then pressure should be high. It should be a large value. Okay, so this is a very important concept in our day-to-day lives also. For examples, let's consider a storm. Okay, there is a house like this, and there is a high flow of wind, a storm. So wind is flowing like this over the roof. So here wind can flow like this. The streamlines are like this, and when it flows over the roof, it can't go through the roof. Therefore, the streamlines, the particles, will flow somewhat like this. So here the area. So if you consider this as a tube of flow, the area has decreased. So if the area is small, velocity is high. Here velocity is high. So at this position, velocity is high. Therefore, pressure is low. If you consider below the roof, inside the house, velocity is almost constant. Velocity is almost a zero value inside the house. If not, velocity is low, comma. Therefore, pressure is high. So what is the end result? The end result is, let me just erase this and write it somewhat below. Okay, velocity is zero, that means velocity is small compared to this position. Pressure is high. From higher pressure to the lower pressure, there is a push. Here the pressure is high, air pressure is here high, here it is low. So there is a force. There are forces acting on the roof. So what will happen? Means the roof it will just throw away, or it will just drag with the wind due to this force exerted from inside the house. It can happen, right? Then you can draw this only this diagram below the first example. Below the first example, don't write anything about this line. Just draw this diagram below the first example. These are forces, okay? These are forces. F. All these are forces. Get the idea that when the streamlines comes close to each other, that means it is same as area becoming smaller. These particles now have a smaller area to flow through, so velocity becomes high. That is the case.